Hello everyone. In this large language model or LLM tutorial, we explain how to install and use Llama 3.1 in Python and Windows. This is the second version of the tutorial where we do not use Anaconda. Instead, we just use basic Python and the command prompt. That is, we will use ordinary Python virtual environments to install Llama 3.1 instead of using Anaconda or Conda virtual environments. We will thoroughly explain all the steps you need to perform in order to properly install and use Llama in Python on your local computer. The complete installation process might take more than an hour, so prepare yourself. That is reserved time. Here is some background information for those of you who are not familiar with Llama. Llama is a family of LLMs or large language models released by Meta AI, and Meta AI is formerly known as Facebook. The newest version of Llama is Llama 3.1, and according to the tests, it outperforms other LLMs. Also, smaller models can be run locally on a computer. By the end of this tutorial, you will be able to write a Llama script in Python on your local machine, and the script will be able to provide you with intelligent and AI-generated answers. The script will look like this. I will explain this Python script later on in this tutorial. The main thing is that over here, we will ask a message or actually ask a question. What is a transfer function, for example? And over here, we will print the response. By watching this tutorial, you will be able to properly install Llama 3.1 in Windows and Python, and you will be able to write this simple script that will ask a question to our Llama 3.1, and Llama 3.1 will generate the answer. So this is how we ask a question. This is a Python script. So let's over here change the question, and let's, for example, ask how to make an orange juice. Okay, so let's do this, ask a question, save this file. Let's go back to the terminal, and over here I'm running Llama in a Python virtual environment, and I will teach you how to write such a Python virtual environment, install everything, and here's our file that we need to run. Here it is, and let's run it. Over here, while the computations are performed, we can simply open Task Manager and we can look at the memory consumption of GPU. You can see what's happening, and everything's happening in real time. So we are running the model is creating inference, computing the results, and here it is. Ingredients, 4 to 6 oranges depending on their size and your desired juice yield, and you can see equipment, instruction, and that's it. Really makes sense. This means that Llama works perfectly. Here are the software and hardware prerequisites for installing Llama 3.1. First of all, you will need a GPU, although you can also use a CPU. In my case, I'm using NVIDIA GeForce RTX 3090. It takes less than 10 seconds to run a Llama 3.1 model on this GPU. The model has around 8B parameters. However, you can also run Llama on CPU if you know how to optimize it. And this is not difficult, but you will have to do some trials and error. Then you will need Visual Studio C++ Community 2022. This is a free version of Visual Studio C++. If you don't install it before installing PyTorch, and PyTorch is necessary for Llama 3.1, you will not be able to run PyTorch, and you will experience some issues with DLL files. So make sure that you have these two things, and in this tutorial I will actually install Visual Studio C++. So I will explain you how to do that. This means that you only have to have a GPU, or if you know how to optimize Llama on CPU, then you can just use a CPU. Okay, let's start. The first step is to download and install Python on your system. Over here, I assume that you don't have Python installed on your computer. However, if you have Python, simply skip this step. However, my suggestion is still to go over this step, since you have to set up Python such that it is in your system path and such that you can run it from the command prompt. So click here on Download Python and wait. Now I will open this folder, and then I will double click over here, and then I will click on Install Now. here, I will use this option and I will use add Python executable to system path. This is very important since I want to be able to run Python from my command prompt. So click over here and I will click yes, and let's continue with the installation process. And here you need to be patient since this will take some time. And after some time you will see this window, and over here I will click here just to make sure that this is closed. So close this. Next, let's test Python. To test Python, open this, actually click on start and search for command prompt. Over here in the command prompt, simply try to type Python. And here it is. Good. This means that we have successfully installed Python, and you can see the Python version. So let's exit. And another thing that we need to verify is that we have pip, and we actually have pip, which is also good. Next, let's verify that you actually have a GPU installed on your system and that your system, that is Windows, can recognize GPU. So let's type this NVIDIA SMI, this command, and this command will actually print this message. You can see that I currently have a GPU on my system. You can see it's GeForce RTX 3090, you can see the power consumption, you can see the memory, and you can see CUDA version. Good, this is very important, and we can proceed. The next step is to install the Visual Studio C or C++ IDE and compiler for Windows. Again, if you don't have this program installed, you will not be able to successfully install PyTorch, and you might have some issues later on with DLL files. So let's learn how to install it. So search Visual C++ compiler and go to this web page, and over here search for Community Edition. The Community Edition is completely free, and if you click on the link you will see that the file is downloaded. Visual Studio setup.executable. Go over here, open it up, click on yes, and over here you have to be patient. This will take probably like 5 minutes or something like that, depending on how fast is your connection. So you see now here it's being installed. Again, it's 5 GB. It's a pretty large program. However, make sure that you have it, otherwise you will not be able to properly install PyTorch. After you install the Microsoft Visual Studio, make sure to restart your computer. And after you restart your computer, you can start again watching this video tutorial. Next, we need to download the Llama model. To do that, we need to go to this website called Hugging Face. Hugging Face is similar to GitHub, and it's used to host and even to run machine learning model. And we need to download Llama 3.1 model from Hugging Face. To that, you need to sign up. Again, if you have a Hugging Face account, you can simply skip this step and you can directly log in. So I will use my email address. I don't use this email address very often, so do not write me emails to this email address. You have my contact information below description of this video. And over here I will set the password, and you cannot see my password, of course. Okay, and I will click on next. I will click not now, and over here you need to fill in your data, and I'm not going to give you my information. Over here I will simply continue the video after I fill in this data. However, fill in this and then click on create account. Once the registration is completed and your account is verified, you will be able to log in. After you log in, you will see this main menu over here, and over here you can search for models. So type here Meta, or actually type Llama over here and search for this model. If you don't see it immediately, this model, just type Meta-Llama, then give this model name. Actually write this model name. So click over here, and our next task is to download this model, or better to say, to gain access to this model. To do that, you will need to go over this community license agreement. So expand here, go all the way down, all the way down, all the way down. And over here, you need to fill in your information, and you need to click here and you need to submit. After that, your request will be processed and you might have to wait some time for the request to be approved. Usually it takes like 10 or 15 minutes to be approved. And over here, I will enter my information and then I will click on submit. Again, I will not film what I'm typing over here since this is a private information, and I will lead you and I will start filming again once I click the submit button. After you complete this form, you can simply click on submit. And now over here you will have to wait for some time, since you will see this message: your request to access this repository has been submitted and is waiting a review from the repository authors. Okay, you can check the status of your request in your settings. So click over here on your settings and you can see that the request is still pending. You can also go to this settings window by clicking here and clicking on settings. And if you go all the way down, you will click here on gated repositories, that is over here, and you will see your request and it's pending. Now, you have to be patient. This might take 15-20 minutes depending on how busy they are. Or maybe it is just some automated system that has some delay, since a lot of people are requesting requests. Okay, so be patient over here. Okay, so approximately after 10 minutes, this request status changed to accepted. Good. The next step is to create our token. Namely, to be able to download Llama 3.1 on our local machine, we need to actually create a password or a token. So let's learn how to do that. So click here on Access Token and click on Create a New Token. And over here, give a token name. And after that, you will need to do one additional thing. That is, you'll need to click over here. And after that, you will create a token. So I will call, for example, my token name. And this can be even public information. I can call it like token 1. Anyway, even if you see my token for installing, I'm going to erase that token so you will not be able to use it. However, still, as a precautious measure, I will not show you the generated token. So once you enter your token name, this is simple ID and not a real token, you will basically go all the way down, but again, don't forget to click over here, otherwise you will not be able to download the repository, and then click on Create Token. After you create a token, you will see a new window will pop up, and your token consisting of characters and numbers, for example 30 characters and numbers, will be created. Copy and paste that token and save it somewhere such that no one can see it. So I'm not going to film after I press this, since you will be able to see my token. Later on, you will use that token. After you created your token, click over here on Gated Repository, click over here, and you will obtain information over here. This means that you have the access to Llama 3.1 and you can download. So where are the files? The files are actually over here, and you can see that it's a complete repository that resembles a GitHub repository. However, we are not going to directly download from here. What we will do, we will open a command prompt, we will create our workspace folder, and then we will git clone this repository. Consequently, let's do these steps. First of all, let me close the original terminal, and over here I will start a new command prompt. And in this command prompt, I will go to my root C drive, then I will go to the folder that's called codes, and in this folder I will create a new folder called Llama 3.1. Okay. Then I will navigate to my Llama 3.1 folder, and in this folder I will clone, or better to say download, this remote repository. That is, I will download this repository. So let's learn how to do that. To download, or better to say to clone Llama 3.1, we need to execute this command in our terminal. However, over here you need to enter your user information. First of all, you need to enter your username on Hugging Face over here, and the username will be entered without these angle brackets. Then you need to enter over here your token, again without angle brackets. Then you need to add at huggingface.co, and over here I will erase this part so I can show you how to download any model. Okay, so let's go step by step. First of all, let's figure out what's our username. So go to Hugging Face, click over here, and you can see a profile. This is your username. However, if you're not sure, click on Settings, and here's your username. Okay, so this is my username. So I will simply copy and paste. I will go here, and then I will here type it. So erase this, and I will simply paste it. Okay, so this is my username, no space. Then I'm not going to enter token. However, over here, you'll enter your token. It will look somehow like this. Then over here, we need to enter the path to our model. And how to do that? Well, go back to Hugging Face, go back to over here under Settings, go to the gated repositories, click over here, and this is the thing that you need to paste. So click over here, and this is the path to your model with respect to the Hugging Face, and you can see it over here actually. So go back here and simply paste this. Let's just do this, no space over here, and this is the command that you need to execute in your terminal. So go copy and paste this, go to the terminal, and over here execute this, and I will execute this once I change my token over here, and I'm not going to show you the token name. So what will happen after you execute this? The download or the clone process will start, and it might take 30-40 minutes to download. You're downloading probably 20 or 30 GB of model parameters, and be patient. The system is not stuck, the system will download. Okay, I will come back once I enter my token, and I will continue to. After you execute git clone, you will see this message, cloning into this folder, enumerating objects, counting object, total 96, and you can see the download speed. To be honest, this is not a great download speed, and it will take 20-30 minutes to download. However, this is the problem. Hugging Face is a big server, and it has a lot of requests from all over the world. Consequently, you have to be patient. It will download, however, it might take time. Another important thing to observe over here is that sometimes over here it's good to press space or enter, since this window is sometimes not refreshed. So although if you don't see anything over here, something is happening behind the scenes. So from time to time press enter or space to kind of update the screen. This is what I realized. How do we know that we are actually downloading the model? Well, if you click over here, and if you go to your C codes, Llama 3.1, you will see the folder. And if you click on the folder, you can see that the folder is being created and the files are being downloaded. And you can see the time, 2:36. I started the process somewhere around 2:32 or something like that. And you can see something is being downloaded, you have git, etc. Good. So be patient. So after approximately 30 minutes, the download process is completed. And now if you type this command, you will see that we actually have downloaded the folder. So let's verify it by going to this folder and typing again the command, and here it is. These files over here are actually the model parameters, and you can see how big they are. They're extreme. Okay, the next step is to actually install PyTorch and some additional packages that will help us to run this model. To do that, we will create a Python virtual environment. So I will close this window and I will start from scratch. Click on Start, search for command prompt, then let's go to our base folder. In my case, it's in codes, Llama 3.1, and here it is. Okay, in this folder we will create our Python virtual environment. Python virtual environment will enable us to install local packages that will not affect the packages of the base Python distribution. That is, we will simply have a controlled test environment where we can test the code, we can play with Llama without fear to interfere with the base Python packages and without fear to create some errors in a base installation. So let's create this environment. To do that, you need to type Python with the option M. venv is the command for creating the environment, and let's call the environment as environment1. Over here, you have to be patient a little bit and wait. Now, if you see again the structure of your folder, you will see another subfolder called environment1. All the packages will be installed in this folder. Next, let's learn how to activate this environment. To activate this environment, we actually need to execute a script file from environment1 folder, and we do that by specifying path to that file. And here's the path. In your case, it will be the same. And magic happens. You can see here in parentheses, we have environment1 activated. Good. Now we can start installing packages. First of all, we need to install PyTorch. And as I mentioned previously, to properly install PyTorch and to run it without errors, you need to have Visual Studio Community Edition, and I explain how to install it. So make sure that you properly follow that step. Over here, you need to select pip, Windows, Python, and over here you need to choose your CUDA version. The CUDA version is important, but it's also not important. Namely, if I go back to my terminal and if I type this, let me just SMI, this is the command, you will see over here my GPU. And you can see that I'm using CUDA version 12.2. However, over here you don't have CUDA 12.2, so you need to choose one of these versions. I discovered that it really doesn't matter the version you will choose. I will choose this version over here. And then depending where you click, right, I clicked over here, you can see that we need to execute this command. So let's copy and paste this command from this website, and you can see the address of the website. So let's go back to our terminal, and in this terminal we need to run this command. And this command will install PyTorch. And here you need to be patient. This might take probably 4 or 5 minutes to install. So be patient and wait. After installing PyTorch, we need to install Hugging Face Hub. We do it like this, pip install Hugging Face Hub. Let's execute this and let's be patient. Again, it will take some time to install this. And now you can do pip list to see the list of packages to make sure that the proper things are installed. And you can see that we have Torch, PyTorch, and a bunch of other packages. Next, we need to install several other packages. We need to install transformers. So let's run this, pip install transformers. And again, this will take some time, maybe even a little bit longer. And be patient. And finally, we need to install pip install accelerate. Okay, the next step is to create our first Llama program that will demonstrate how to use Llama. To do that, I will create a new file, a new Python file using Notepad, and I will call it test1.py. Of course, you can use any other Python editor. And I'll create a file, and here's the content of the file. And let's explain this file line by line. So what do we do over here? First of all, from transformers, we import pipeline. Then we import torch. This line will import PyTorch. Next, we need to specify the path to our model. So how to find the path to our model? Well, go to the folder where you installed Llama, go to this folder, simply copy this path over here. And then let me show you what you need to do. I will keep it as a comment. So instead of these backslashes over here, you need to enter double backslashes, right? I'm not sure do I correctly pronounce this character, however I will call it backslash. So you have a double backslash, double backslash, double backslash. That is, a single backslash in a Windows path is over here, double backslash. So I will erase this such that I don't change my file. Then we need to define our pipeline. First of all, we say text generation, comma, we specify a path to our model. Okay, here it is. Then we put some arguments. We are using float 16, and we specify CUDA over here. This is very important to explicitly say CUDA. Mainly if you omit CUDA, you might be running a CPU version of Llama and might be slow. So make sure that you have CUDA, and over here is the main line. Here we ask a question, and over here I will ask a question. I will change this question, how to solve a quadratic equation, and do it like this. Okay, good. Next, we need to define our response. Again, we use pipe. Over here, we specify a message that we are sending. That is, this dictionary over here will contain a question, and here's the question. Then we specify some Llama parameters such as max new tokens, and let's say 256, and you can change and play with this parameter. However, it might take longer time to generate a response. Then we do this option, do sample is equal to false, and of course you have probably 10 or 20 additional options that are used to tune your response, and you can play with them. You can look at the other options at the Llama website. And over here we extract the response once the response is computed, like this. And finally we print the response. Simple as that. Save this file, close it, go back to this terminal, and let's execute our file. So simply type python test1.py, and let's hope that everything will be fine. And here you have to wait. This will take some time to execute. Okay, we are loading checkpoint model. Very good. So the model is being loaded, and now you can see how in real time everything is being computed. You can also click here on Task Manager and search for performance. You can see basically CPU over here in GPU, and you can see that the memory of GPU is being consumed, and over here you can see the response. So here is the response. If the quadratic equation can be factored into the product of two binomials, we can solve it, and you can see that this response really makes sense. And here is the second method for solving the quadratic equation by using quadratic formula, and here is the instruction. And that's it. You can see actually that my answer is truncated. This is because I specified a relatively low number of tokens, and of course you can additionally increase the number of tokens and play with the network parameters to improve this response. And that's it. Simple as that. So nothing special. However, I must admit that the installation process might be tedious for some user. However, you have to follow it.